Welcome to Study Loop.
So here for the upstream trip, the boat will cover so let's say upstream trip. The boat will cover a distance of d over 2, so half the distance, with a net speed of, you can say speed net, equaling the velocity of the boat minus u. So t sub 1 would be equal to d over 2 divided by v minus u, and this would equal d over 2 times v minus u. For the downstream trip, again, we are covering a distance of d over 2. However, here the net speed is going to be equal to v plus u because now the water is working with you. So d over 2 would equal, t sub 2 would equal d over 2 divided by v plus u, and this will equal d divided by t, d divided by 2 times v plus u. And so we can say that the total time would be equal to d over 2 times v minus u plus d over 2 times v plus u, and this is equaling dv divided by v squared minus u squared. So this would equal the total time, and again, this would be for part A. And then for part B, let's draw a diagram. Draw those lower. This would be our angle here, theta. And up here would be the velocity of the water relative to the shore. This is equaling vector u. And then here, this would be the velocity of the boat relative to the shore. And this would be the velocity of the boat relative to the water. This is equaling vector v. So we can say that the velocity of the boat relative to the shore will be equal to vector v plus vector u. And at this point, we know that we can find the magnitude of the velocity of the boat relative to the shore, or rather the magnitude, and this would equal the square root of v squared plus u squared to the 1/2 power, or at the square root. And the time to go a distance d2 across the river, we can say that t sub 1 would be equal to d over 2 divided by the square root of v squared my apologies, this is actually negative. So it would be v squared minus u squared, and this would equal d over 2 times the square root of v squared minus u squared. And then the same relationship would be for crossing back. So here, t sub 1 would equal t sub 2. Therefore, the total time would be equal to 2 times t sub 1, which would again be d over the square root of v squared minus u squared. This would be your answer for part B. Now, the speed v must be greater than the speed u because the velocity of the boat relative to the shore going upstream would be v minus u. So if the velocity here, if the velocity of the boat relative to the water was less than the velocity of the water relative to the shore, that means that the water would be carrying the boat, and the boat would actually not move upstream whatsoever. So going upstream here would be actually impossible, because we would not be able to overcome the current, essentially. So here, again, the velocity of the boat relative to the water must be greater than the velocity of the water relative to the shore. That is the end of the solution. Thank you for watching.